It's been months since you and your crew have been roaming in space. Everyone is a little homesick by now. The spaceship has reached so far out in space that some of the crew members have lost hope of returning home. You're checking all the analytics of the spaceship while your partner sits next to you. Captain, don't you ever think what it's like back home? No, this is not the time to daydream. We have to collect all information and complete this mission. Your partner frowns. All I ever think about these days is eating hot dogs and slurping on a watermelon slushie. Deep down, you knew that you were all lost in the middle of space, with no means of rescue. This is not the time for your jokes. Get back to work. Your partner screams out, "Captain, we're all going to die." You push him aside and you call all crew members to assemble and assign everyone their duties and gear up to head out to check the damage on the outer rear side of the spaceship. The thought of leaving the spaceship makes you shake, but you have to be strong to keep the team together. As you float to the back of the spaceship, what you see shocks you. A mini spacecraft had collided into your one, and there was a man on board unconscious. You hurry to reach him to safety and bring him into the spaceship and arrange all necessary health equipment. Hours later, the man jumps up. "Where am I?" As the crew members rush to his attention, he screams, "It worked! The wormhole worked! We can all get back home!" You only wish it were real. Considering all the movies that have come out in the recent time, we all are science fiction fans. But sadly, as the name claims, it is only fiction at the end of the day. You have probably heard of wormholes, a special portal that helps you jump through space-time. Wormholes are the perfect solution to any problem, be that in the far reaches of space or simply back at home. Let's imagine. Alien attack? What to do? Open a huge portal and either you jump in it to safety, or let them fall into it to the middle of nowhere where they cannot return. Or when you're back at home, stirring your coffee, accidentally drop your spoon, open a wormhole that leads back to your cup so the spoon falls into it, and the spoon falls nicely back into your hot, half-stirred coffee. Or on a bigger scale, imagine a deadly creature. A sharp knife, a bullet, a scary doll, or a scary nun. Whatever it is, open that life-saving wormhole and relocate everything to Sakhar. Wormholes are the perfect solution to any situation, and according to Einstein, they are the solution to his field equations for gravity that act as tunnels connecting points in space-time, so that the trip between the points through the wormhole would take much less time than the trip through normal space. Basically, wormholes allow nearly instantaneous travel between 2 points that would otherwise take an extremely long time to travel between through normal space. But the question is it real, or at least to a certain extent? Unfortunately, scientists are people who don't have answers to most of the interesting points about life. But nevertheless, we depend on them to give us a clue. Click here to watch some of the simplest things that scientists scratch their heads about. Scientists say the kind of wormhole we fantasize about definitely does not exist, and no evidence has ever been found about all other possibilities. The first wormhole-like solutions were found from studying Einstein's field equations for gravity and his mathematical solutions for black holes, which suggested geometric interpretation that looked like 2 black holes connected by a throat or tunnel called an Einstein-Rosen bridge. Since then, other scientists have suggested that the entrance of a wormhole might be a black hole, while the exit would be a theoretical white hole. But no evidence has ever been found of either wormholes or white holes by any scientist. Some scientists believe that if wormholes exist at all, they might only exist on a subatomic scale for fractions of a second, while other scientists believe that wormholes don't occur naturally, but they can be made using something called exotic matter. But, like wormholes, which are only a theory at this point, exotic matter is also only theoretical. So it is highly unlikely that you will hear that a scientist has finally discovered wormholes that allow intergalactic travel, at least in this lifetime. But say if one day we were able to discover a wormhole and were able to enlarge it with exotic matter, could we be able to travel here and there in a blink of an eye? Most likely not, as scientists say that inserting anything into a wormhole would cause it to destabilize and disappear, destroying whatever you put into it. Scientists also suggest that wormholes, by their very nature, would also allow us to travel back in time. While time travel sounds pretty awesome, just think about what effects your actions might have if you change the past. Something we have all learned if we have learned anything from Flash. One thing is for sure, time travel is the most disastrous thing that you can do to the timeline. The possibilities are endless, and allows for a variety of paradoxical situations, known as the grandfather paradox, where if you happen to go back into the past and kill your grandfather before your father was born, and so you would not be born either. And in this life, you know there is no real Flash, the fastest man alive, to save the day. Although wormholes are just science fiction at this point, black holes are not. But unlike wormholes that put an excited smile on your face, hearing about black holes often fills us with dread. A black circle opening up and sucking everything that exists into it. And to reach where exactly? No one knows. Even if that might not be the most accurate depiction of a black hole, just imagining it gives us chills. But it's not something we can just put aside, as they do actually exist, unlike wormholes. So let's learn a little about black holes now. What are black holes? A black hole is defined as a place in space where gravity pulls so much that even light cannot get out. Due to the matter that is being squeezed into such a tiny space, the gravity is so strong. Scientists say that the smallest black holes are as small as just one atom. While these black holes are very tiny, they have a mass of a large mountain. Larger black holes are called stellar. Its mass can be up to 20 times more than the mass of the Sun. Scientists believe there may be many stellar mass black holes in Earth's galaxy. The largest black holes are called supermassive. These black holes have masses that are more than 1 million suns together. Scientists have found proof that every large galaxy contains a supermassive black hole at its center. The supermassive black hole at the center of the Milky Way galaxy is called Sagittarius A, which has a mass equal to about 4 million suns and would fit inside a very large ball. Scientists suppose the smallest black holes formed when the universe began. Stellar black holes are made when the center of a very big star collapses. When this happens, it causes a supernova, an exploding star that blasts part of the star into space. Supermassive black holes are thought to be made at the same time as the galaxy they are in. Can we see a black hole? No. As light is unable to escape the hole's gravity, it appears completely black, hence the name black hole. The event horizon is the outermost boundary of the black hole. This is literally the point of no return, where the gravitational force precisely overcomes light's ability to escape the black hole's pull. Until very recently, scientists have believed that as light cannot escape once past the black hole's event horizon, they can't be seen in the traditional sense, or by even observing them with telescopes that rely on X-rays, light, or any other form of electromagnetic radiation. Until now, we have only been able to infer their existence by the gravitational impact on other nearby matter and objects. Detecting them requires a bit of lateral thinking. For example, if a black hole passes through an interstellar cloud, it would draw matter inward towards the black hole in a process known as accretion. Stars can be torn apart or be deflected from their normal motion if they pass near a black hole. Recent discoveries have found evidence to show the influence of black holes on its surroundings, from emitting powerful gamma-ray bursts, devouring nearby stars, and the growth of new stars in some areas. In April 2019, scientists took the first ever picture of a black hole. It is an image of a dark circle surrounded by a ring of light in the center of a galaxy known as Messier 87. Astronomers reached across intergalactic space to M87, which is about 55 million light-years away from Earth. It is a giant galaxy in the constellation Virgo. The black hole there is many billion times more massive than the Sun and is releasing violent energy about 5,000 light-years into space. After 2 years of observations by over 200 astronomers around the world from a network of radio antennas called the Event Horizon Telescope, in April, scientists synchronized all the telescopes to measure the radio waves being emitted from the black hole all at the same time. From this Earth-sized telescope, scientists were able to capture this image of a black hole. Looks pretty blurry, but with the current technology we have, this is the highest resolution achievable. And let's not forget, we are imaging a black hole that's 55 million light-years away. And then again, this is not a picture taken in the traditional sense. With the measurements of the radio waves that were being emitted, scientists processed that information with a computer to make this image that we are seeing. From the image, we know that Einstein's prediction was right after all. He predicted that the event horizon can be seen, and turns out it's true. The dark circle at the center is indeed the shadow of the black hole, which is surrounded by the glowing gas present in the event horizon. The most intriguing question of all, what is at the center or in the black hole? But maybe we might not find any answer. Kip Thorne, an American physicist, describes this point as where all the laws of physics break down. At the center of a black hole is something called a gravitational singularity, where gravity and density are infinite. Space-time curves infinitely, and the laws of known physics are thought to no longer apply. This is the final destination for anything that strays too close to the black hole. No one knows for sure what happens as it passes over the event horizon and disappears. So let's say if we fell into a black hole, what would happen? If it's a supermassive black hole, you actually wouldn't feel anything. It would be like a free fall. You would just exist, and then eventually you wouldn't. But for the observer, it's a whole different scene. As you reach the event horizon, you will appear to immediately accelerate, stretch, and distort. And as you get closer to the event horizon, things will get slower until you freeze, and as you remain motionless, you will stretch and start to heat up. Then you will begin to slowly obliterate as you stretch across the curved space-time of the black hole. Finally, you would be down to only ashes before your remains would appear to be sucked into the absolute darkness of the black hole. Sounds scary, but to make things better and lighten the mood, black holes do not go around in space eating stars, moons, and planets. No black hole is close enough to our solar system for the Earth to be pulled into it. Even if a black hole the same mass as the Sun were to take the place of the Sun, we would all be safe and sound on Earth. The black hole would have the same gravity as the Sun, and the Earth along with the other planets would orbit the black hole as they orbit the Sun now. Having said that, the Sun will never turn into a black hole. Only stars with large masses can become black holes, and the Sun is not a big enough star to make a black hole. So no need to have nightmares, you can sleep in peace.